Today we're going to finish section 6.1 when talking about angles in radian measure. So remember in chapter 5 we talked about how we find coterminal angles. Well, if we're finding coterminal angles for radian measure, instead of adding and subtracting 360, we're going to add and subtract 2 pi, because there are 2 pi radians in a full circle. So let's take a look. It says find the smallest positive coterminal angle between 0 and 2 pi. So we want to get our answer between 0 and 2 pi. So notice for number 1, my angle is negative square root of 13 pi over 6. So I want to make it positive, so I'm going to take and add a 2 pi to it. If I add 2 pi, because I'm adding it with a fraction, I need to get a common denominator. So the common denominator is 6. If I multiply the top by 6, that's going to turn into a 12. So if I add those two together, I'm going to still get negative pi over 6. So it's still negative, so I'm going to continue to add 2 pi until it becomes a positive value. So I'm going to say plus 2 pi again. Again, I have to get a common denominator, so that 2 is going to become a 12. So negative pi over 6 plus 12 pi over 6 is going to give me 11 pi over 6. So 11 pi over 6 is the smallest positive coterminal angle between 0 and 2 pi. Now let's look at number 2. If I take a look, 13 over 3, if I said how many times does 3 go into 13, it goes a little bit more than 4 times. So that's larger than 2 pi. So I want to make it smaller, so I'm going to subtract 2 pi. Again, if I subtract, I have to get a common denominator. In this case, my common denominator is a 3. So that 2 is going to become a 6. So 13 minus 6 is going to give me 7 pi over 3. Well, if I take a look again, 7 over 3, 3 goes into 7 a little bit more than 2 times, so it's still larger than 2 pi. So I'm going to subtract again getting a common denominator, so it's going to become 6 over 3. So when I subtract, I'm going to get pi over 3 as my final answer for the smallest positive coterminal angle. So we're going to have to use these finding coterminal angles a little later on when we're evaluating functions. Another thing we may have to use when evaluating functions is finding the reference angle for each angle given. So remember, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, the breakdown of our quadrants for radians is going to go 0 to a half pi to 1 pi to 1.5 pi or 3 over 2 and then to 2 pi. So if it's between 0 and pi over 2, your reference angle is just going to be theta. If it's between a half pi and 1 pi, in order to find your reference angle, you're going to say pi minus theta. If it's in quadrant 3, it's going to be between pi and 3 pi over 2. So to find that reference angle, you're going to say theta minus pi. And last, if it's in the 4th quadrant, it's between 3 over 2 and 2, and to find your reference angle, you're going to say 2 pi minus theta. So let's look at some examples. So the first thing we're going to do is determine what quadrant we're working in. So if I take a look, 7 over 6 is a little bit more than 1. So if I go, here's 1 pi, here's 1.5, so it's going to be somewhere in quadrant 3. So this problem is in quadrant 3. So to find my reference angle, I'm simply going to say 7 pi over 6 minus pi. Again, I have to get a common denominator, so I'm going to multiply the top and bottom by 6. So 7 pi over 6 minus 6 pi over 6 is simply going to give me pi over 6. So pi over 6 is going to be my final answer. Now let's take a look at number 4. So 5 over 9. 5 over 9 is a little bit more than a half. So if I go up here, okay, if it's more than a half but less than 1, it's in quadrant 2. So we're going to be in quadrant 2. So the reference angle rule for quadrant 2 is going to be pi minus theta. So pi minus 5 pi over 9. Again, I'm going to get a common denominator. So I'm going to multiply the top and bottom by 9. So 9 minus 5 is going to give me 4 pi over 9. So my reference angle in this case is 4 pi over 9. Last, if I take a look at 25 over 6. Well, 6 goes into 25 almost 4 times, or a little bit more than 4 times. So we can't find we can't determine what quadrant it's in. So first thing we're going to have to do is find a coterminal angle. So I'm going to subtract 2 pi. Again, get a common denominator, so that's a 6. That'll become a 12. So I'll get 13 pi over 6. Well, 13 over 6 is still larger than 2, so I again need to subtract. Again, I'm going to get a common denominator, so that becomes a 6. The top is going to become a 12, so I get pi over 6. Well, 1/6 is less than 1/2, so that means I'm going to be in quadrant 1. Well, if I come up here and look, quadrant 1 is simply the angle, so my reference angle is simply going to be pi over 6. All right, now let's go ahead and put these two concepts together. All right, so it says evaluate the following functions using the unit circle. Well, the first thing we're going to do, I'm going to draw this up here. We didn't get to talk about this last class, so I'm just going to give you the first quadrant. So the first angle right here, that's 30 degrees. Well, if I convert 30 degrees to radians, that's going to be pi over 6. Then my second angle, that's 45 degrees. Well, if I convert that to radians, that would be pi over 4. And then my last angle is 60 degrees. Well, if I convert that, that's going to be pi over 3. So those are the 3 angles in radians that are going to show up in the first quadrant of your unit circle. Well, let's remember our coordinates. Our coordinates at 30 degrees or pi over 6 radians is going to be the square root of 3, comma 1/2. Sorry, the square root of 3 over 2, comma 1/2. At 45 degrees, my coordinate was square root of 2 over 2, square root of 2 over 2. And then lastly, my coordinates at pi over 3 radians or 60 degrees is simply going to be 1/2, comma square root of 3 over 2. So we're going to refer to that as we work through these problems. So let's first look at number 6. So just like we did if we were given a degree measure, the first thing we're going to do is determine what quadrant are we working in. So if I take a look at 4 pi over 3, 4 pi over 3 is going to be a little bit more than 1. So that means we're going to be in the third quadrant. So guys, notice you only have 3 choices for your angles. So what would make sense to be your reference angle? If my original angle was 4 pi over 3, it would make sense that my reference angle is going to be just pi over 3. But technically, if we did the work, so quadrant 3, you're just simply going to say 4 pi over 3 minus pi. Again, if I got a common denominator, I would end up getting pi over 3. So pi over 3 is my reference angle. So I'm going to go up, what are my coordinates? Well, my coordinates are going to be 1/2 square root of 3 over 2. So now I'm going to take a look. Cosine, so I'm dealing with cosine. Cosine is my x value. So what is my x value at this coordinate? It's 1/2. So cosine is going to be 1/2. Now the last thing you have to do, if it's in quadrant 3, is my x going to be positive or negative? Well, it's going to be negative, so my final answer is -1/2. So let's go through that process again. So this should be, 25 pi over 6. So we have to figure out what quadrant is 25 pi over 6. Well, in this case, I'm going to have to find a coterminal angle. So I'm going to subtract 2 pi, again get a common denominator, I get 13 pi over 6. Well, that's still too big. So I subtract another 2 pi, I get pi over 6. So essentially the problem becomes tangent of pi over 6. So what quadrant is pi over 6? Well, notice it's already in quadrant 1. So my reference angle is just pi over 6. So if I go up here, what are my coordinates? Well, my coordinates are going to be the square root of 3 over 2, comma, 1/2. Well, tangent is y over x. So I'm going to go ahead and put my y value over my x value. So what's going to happen? The 2's are going to cancel out. I'm going to get 1 over square root of 3. I have to rationalize that, and that becomes square root of 3 over 3. Now, in the first quadrant, everything is positive, so my final answer is going to stay positive. Now let's look at number 8. What quadrant is of 7 over 4? Well, 7 over 4 is a little less than 2. So that means it's going to be in quadrant 4. So again, I can really come up here and look and right away tell you that my reference angle is going to be pi over 4. But technically, you just use your reference angle rule, which says 2 pi minus 7 pi over 4. I would get a common denominator and get pi over 4. Now, I go up to pi over 4. What are my coordinates? Well, my coordinates are square root of 2 over 2, comma, square root of 2 over 2. Well, sine is just my y value. So I'm going to get my y value, which is square root of 2 over 2. In quadrant 4, what is your y value? Is it positive or negative? It is negative, so I'm going to put a negative out in front, and that will be my final answer. For right now, I'm going to stop right there. I'm going to create another video to end the notes that covers arc length and area of a sector. So there'll be a separate video for you to watch on the last part of your notes.